Good afternoon, all. I don't know how many of you attended the training and the Google other sessions, but my name is Abhijeet. I'm part of the data management for Google Cloud, and we have our complete team here. And we have Tushar, Rishi, Saurav, Suresh, Niranjan, and a lot of engineering folks like Pushkar as well, who has done quite a lot of work around AI and Postgres. So feel free to ask questions. We want to have this forum as open as possible. So make most of this time available to you to ask questions. So what we have planned for you today is we'll start with the overall portfolio of what are the options you can run on Google Cloud for Postgres. What are the various ways you can run Postgres, as well as what are the other databases you can run on Google Cloud, like document or memory and so on. So Tushar will cover that piece. Then we'll talk about the what is so differentiating about AI capabilities in Google Cloud, and towards the end we'll touch upon the agentic framework. And we have Abhirami from our DevRel. She will also talk about how developers can benefit from Google's offerings. So with that, I'll hand it over to you, Tushar.
Thank you, Abhijeet. I hope I am audible. Okay, so in the subsequent slides, I'll be essentially taking you through what are the managed databases that we offer in GCP, and then we will focus more on the work that we are doing in PostgreSQL world. So, be it Cloud SQL and later on in AlloyDB, right? So, we are trying to give you the complete landscape, right? So, let's just start it. I think Abhijit already, I mean, presented the agenda that we want to kind of cover today. Yeah, so how PostgreSQL and what are we kind of doing as Google, right, in this arena? So let's start with what is it that we kind of offer. So this is the complete landscape of managed databases that we offer, including the open source based databases which we have cloudified and providing as a platform as a service, and also the native ones towards the right. So I'll just start from the left side, the in-memory database. It's a memory store. So memory store is our umbrella engine that offers multiple engines beneath. So Redis and Valkey and Memcached. Valkey is the latest and the greatest player. As you might know, Redis changed its licensing a couple of years back, so it became a more closed one in that sense. So a new fork was created by a consortium of big players, including AWS, us, and many others, and that is now kind of progressing pretty faster. So coming from field, I can actually vouch for it and tell you that it is indeed making a lot of sense and is getting very fastly adopted by larger enterprises. The next is Oracle database at Google Cloud. It's a marketplace offering, but given as first party native experience in terms of how it is consumed, how it is, let's say, observed once it is provisioned, and so on. The next is Cloud SQL. It is one of the most heavily used platform as a service offering from us. It has three different engines to offer. So PostgreSQL, MySQL, and SQL Server. I'll be talking a bit more on the PostgreSQL part of it, like what is it that we are giving through Enterprise and Enterprise Plus variant of Cloud SQL. The next one is AlloyDB. AlloyDB is again our 100% PostgreSQL compliant database engine. We have done a lot of innovation at various layers, right from the kernel to making it HTAP compliant. Plus, there are a lot of extensions which allow you to build agentic AI applications using the additional extensions that we have done with the Vertex and so on. The next one is Spanner. Spanner is our one of the most differentiated service. It is a distributed relational database which can help you build an application that can run across continents and gives you 5 nines of SLA. So it is, like a very touch-free kind of experience that you get. The next one is Bigtable. Bigtable is a NoSQL database, basically a wide columnar engine. Uh, a lot of other databases came into existence following the paper that was, written by the Bigtable folks originally. Firestore is our MongoDB compliant document database. Again, it has a lot of features to provide in terms of core native database engine, which is DocumentDB, and then lately we kind of introduced the MongoDB API compliance to it. So a lot of people who had been otherwise using, let's say, open source MongoDB and so on, are heavily using the Firestore now. BigQuery is our data analytics proposition. So a lot of data warehousing customers use it. It also has a lot of elements of AI and ML baked into it and works very closely with our operational databases. So this is the spread of our databases. You will see some horizontal functions as well, which is essentially the state of art AI features and framework that we are offering. Again, we will be talking exclusively about it, and you can kind of then later on also ask questions around it if you have, right? But the MCP toolbox for databases, the ADK framework, and our support for other models as well through the Vertex AI Model Garden makes it a very inclusive kind of offering, and it just kind of takes the overall proposition to the next level. Okay, so what is it that we kind of do, right? I mean, as Abhijeet said, there are a lot of product areas, I mean, representation from different departments within Google Cloud who are here, including DevRel, engineering, us from field, and so on, right? So we try to contribute at various levels. So to start with, right, Google is a major proponent of open source and open standards. So, I mean, since inception, since like more than last 2 decades, we have been kind of contributing a lot to the community in terms of, for example, we introduced the Kubernetes to the world. You might have heard of TensorFlow, and there are so many other things which we kind of, I mean, built in Google, and then we have kind of made available to the outside world and has found a lot of adoption. I think everyone knows the terminology that I just mentioned, right? So we are so much open in that sense and continue to contribute to that. uh, Purely talking about the PostgreSQL movement, right? The community contribution. So we have a lot of people across the globe in different capacities who work as reviewers, authors, and committers. So I mean, like there are few individuals even based in India, right, who actually keep a track of like how we are kind of let's say doing our work, how many contributions we have done. So I think there's a fairly large amount of work that we are doing in that area as well. So we work in all the spaces, right? I mean, contribution to extensions, how the performance or any kind of like val related activities or so on, right? So we have been kind of doing a phenomenal amount of work and have been kind of contributing very actively towards Postgres. uh, I mean, this is one of the examples that as in like this current event itself, right? Like we contribute, we make our presence felt in kind of quite a significant way. So PGConf, PGConf.dev are different events which happen within India and even outside, right? Where we do participate. There are various papers and presentations and keynotes that we actively, I mean, deliver. We do also kind of in at least in India, we have been kind of hosting the open source community for Postgres in different offices. So I know pretty much that we have been doing it in, let's say, Pune, Mumbai, and other offices where we actually get the open source contributors and enthusiasts together, and we do this call for papers and a lot of brainstorming around it. Uh, Okay, so I'll just again talk a bit about like what is it that we have kind of made available via our Google Cloud platform to the external world for the Postgres, right? So again, this is a subset of the slide that I just kind of presented in the previous one. So these are the engines which essentially offer you 100% Postgres compliant engine or a certain dialect that will still make sense for someone who is coming from the Postgres world, right? So Cloud SQL, as I said, it is 100% adoption of open source community Postgres. We just cloudify it and make it available as a platform to the end consumers. LOIDB, again, something that we started. I mean, a lot of innovation has gone into it at the storage layer, how it processes vals, and how it kind of does the replication and so on, right? There is a variant of LOIDB which is Omni, a very interesting offering for the regulated customers who, for some reason, still need to have, let's say, Postgres that is managed running in their data centers or maybe in some other cloud, right, to make it a hybrid or multi-cloud kind of experience. So PostgreSQL, offering via LRDB Omni. So again, it has a variance to it in terms of a Kubernetes-based offering or RPM-based offering, depending where you come from, what are the regular, practices that you have been following. If you are so much adopted to the Kubernetes way of doing it, then you may as well do it in that way. Or if you want to do it a VM based deployments of databases based on your practice, you can still do that. Uh, the next one is Spanner. So Spanner originally didn't have this PostgreSQL dialect, but because of a lot of customers who came from PostgreSQL world, but at the same time wanted to scale and wanted the features of Spanner, like the 5 nines of SLA and so on, right? So we have introduced a PostgreSQL interface, which essentially supports a lot of, let's say, the data types and the dialects that, PSQL, let's say, for example, can actually connect directly to it. So while the core remains what Spanner has to offer natively, we allow and we enable our end users to start talking to it in a PostgreSQL dialect. I already spoke about it, like what it has to offer. Let's say, for example, the PG vector and the additional extensions which make and what you call enable the users to kind of start doing, let's say, RAG based use cases or any kind of vector search, semantic search, and lot more, right?
Any questions so far before we go to the next section?
Yeah, so you can ask if it is something that is not going to take more time, then we can kind of take it right away, or else we can park it for towards the end so that anything that kind of needs to be kind of done in a multi-turn way, we can still do that. So feel free, please. Now let's get into the another area. Now these are like broader topics which are essential to build any enterprise grade application, right? So whenever we are building an application that needs to be served with certain non-functional requirements, for example, how much of availability SLA it should have, what kind of business continuity plan it should adhere to, the security, the performance SLAs, the latencies, the read-write ones, right? So on. So there are so many factors which contribute to it. But how do we think when we have to look at it through the database lens, right? While there are so many other components we have to consider, the database becomes one of the most critical ones, because if your database is not available or it is not performant enough, the user experience is going to deteriorate for sure, right? And assuming that you all come from database background or work very closely on that, you might kind of appreciate or acknowledge what I'm just saying, right? So let's start with high availability, right? So why high availability is non-negotiable in first place, right? So the database is the backbone of any kind of application. So talk about any telcos or bank or any e-commerce site, right? If your database is not performing or it is down, then it is pretty much that your user is not able to do the transaction. So be it doing a transaction on UPI or booking an order on any e-commerce website. So everything just comes to a standstill, right? And it has many consequential impact on the reputation of the organization. If it is a regulated customer, then there could be some penalties that come your way. Let's say if you are doing it for a bank, and if it incurs a downtime, there is a regulatory body, for example, Reserve Bank of India or SEBI or whatever, what that particular industry is aligned to, right? So there's a lot of consequence that comes along with it. There is reputational loss and so on. So we have to design it in such a way that it abides by the criticality of the application. So HA and DR have to play a very critical role, and it has to be done as a pre-thought, right? At the time of design itself, as the first principles or the design principles when we are doing the architecture for the same. Recovery point objective and recovery time objectives are like those very foundational terminologies which will define like what is the need or how that application needs to be built, right? So for critical applications, the RPO could be, if it has to do a cross-region failure, it could be as low as 5 minutes or something in that range. RTO is typically again in the same range, right? Depending on like how we want to do it. Within the region, many times they are zero, as in like you have to have that redundancy built in so that your commits happen accordingly. Okay, so what are the components from PostgreSQL world that come into play, right? So the few ones, like the 4 ones that I have kind of mentioned over here, is first is this replication, which is essentially to build in the redundancy, so that you have more than one copies of your data, be it in the same region. I'm talking in the context of cloud world, where we have a region, and region will have multiple availability zones. So think of availability zones as those logical data centers that have separate power, cooling, and other things. So they are sort of decoupled in a way, right? So we have to have this replication. The other is like, what is the failover mechanism, right? Should one, the primary, which is like a single master construct, if the master goes down, someone has to take over, and that has to happen seamlessly. That has to happen very quickly without loss of data, right, within a region. So failover. The third is connection pooling. I mean, we are building it as an enterprise grade application. We are not going to have like 100 users or 200 users. We might have many thousand users at any given point in time, or depending on what kind of traffic pattern it has to support, right? So connection pooling has to kind of be also a very important consideration, because you don't want to have as many connections, uh, I mean, creating processes at the DB level, because it's going to consume resources, memory, CPU, and whatnot. So you have to be very considerate and thoughtful about it. The fourth one is the load balancing part. Again, as I said, we are building a huge application or a large enterprise applications. Most of the times there are they are read heavy, as in like there will be large number of read queries as compared to write queries that happen. So let all writes go to the master, read your own writes also go over there to the master, but rest of the other modules, which are essentially selects or inquiry statement kind of things, they might as well go to the read replicas, which are through physical replication or other mechanism getting hydrated with the latest of the data. So these are like 4 important considerations that one should bake into your design construct, so that what you are building will last much, beyond what we have kind of, let's say, started with. Okay, the traffic might be smaller in the beginning, but if it picks up, it can go to any level, right? Sorry.
Is there a cross data center replication here?
No, so this is like just consideration or construct. Now, when you say cross data center, are you saying like between 2 data centers or regions of the cloud, or?
Right, across multiple regions.
Yeah, absolutely. So the services that I just alluded to, right? So they do it natively without you having to do the plumbing work. You just have to choose that this is going to be my. For example, in India we have 2 regions. For example, as in like Mumbai and Delhi, right? Asia South 1 and Asia South 2 are the official, nomenclatures for them. So if your primary is going to run in Mumbai, your DR is going to be in Delhi, right? So I create my master/primary in Mumbai, and as part of my provision cycling itself, I create a cross-region replica which is in Delhi. So that in itself kind of sets the underlying connectivity, which is based on Google Cloud's infra, right? So we don't have to do anything, because it's a platform as a service for you. But yes, essentially it's going to be the replication that comes into picture.
So this slide, if you see, is not GCP native services, specific. This is if you have to design high availability using a PostgreSQL yourself. What are the various constructs that you will kind of use?
Yes.
I think
These are the tenets. Yeah.
how we design high availability, right, in a different manner. So, for example, in AlloyDB, it is in a very different manner, right?
Correct.
We design it with a very differentiated storage structure that we have, right? Right. So that is what we are going to delve down deeper into,
Yeah. So essentially, this is like what we are kind of coming to, right?
Sorry, there's a question also.
Oh, sorry, I didn't notice.
Yeah.
Actually, I have seen that normally we are using asynchronous sync, right? For replication purpose. But when you're sending your reads through, how do you decide that there is no lag, so that we can go ahead and read from that replication or not? There should be something like tolerance. Okay, within this much lag only we can go and read there, or it should not go there. Load balancing should happen, routing should happen properly, right? How do you take care of that part?
So see, I think it is again one of the design principles that you have to consider. If it's a read module, what kind of latency tolerance it has? Let's say, for example, the write happened in primary 5 seconds ago, If your read is okay to kind of have a stillness degree of 5 seconds, then you probably kind of are okay to kind of go directly over there, right? So you need to understand your application in that depth. What is available to you as a pass is like you can actually see the latency in real time. Okay, like how far behind is your replica, right? As in like few milliseconds. Typically what we have seen for a well designed data model and schema traffic pattern, it is usually in milliseconds. Okay, now again there are considerations. You could have your read replica running in the same region where your primary is, because the moment it is cross region, there is this law of physics that kicks in, right? But if it is your in the same region, the replica is going to actually give you near real time data, right? So there are different considerations, and of course how you have written your transactions, right? Typically if it is a OLTP transaction, it's going to be a point write that you do, right, at a row level, unlike columnar considerations for OLAP, right? So those kind of transactions, they actually propagate very fast. Even before you realize, you can actually try it out, and that is how I mean like the real world applications are designed. So couple of points: how you design, how you do your writes. For example, if you write a transaction block which is going to, let's say, commit 1,000 let's say 100,000 records and only do a commit, you are just increasing or bloating the size of the transaction, and it's going to throw it as a like a series of val, but going in one way, because only after commit it is going to kind of push forward, right? Instead you can kind of make it small, granular, and that will kind of just make your system more efficient.
Sure. One more point is, if your application requires that you need to be able to read data synchronously, then the choice of database also would change. You would probably rely on an Alloy DB there as compared to a cloud.
Yeah.
So it's also one of the important considerations. So let's say, for example, Cloud SQL, it is based on like how stock PostgreSQL works, as in like single master construct. Each replica will have its own storage, right? And the val will kind of flow over there. LOIDB, which Suresh alluded to, within a same cluster, which is in the same region, it will have a shared storage. So basically the speed of availability of that committed transaction on the read pool node will be relatively faster. But I mean, you can take it from me, if you do it right, even Cloud SQL actually does it very well. Okay, but yes, you have a choice, and there are many other factors that will help you to kind of figure out like whether Cloud SQL is a good choice for you, or a right choice, rather not good choice, a right choice, or LODB it is, right? So while we are kind of treating them all equally, because each of them has their own sweet spot in terms of like how you as a customer or a consumer want to build your applications. So at least for us, it is like having 3 different offerings, and you just pick and choose based on your requirements, right? So coming back to this topic, so Cloud SQL has 2 variants now. One is the erstwhile that has been there for many years, which is Enterprise. Now we call it Cloud SQL Enterprise. And since last couple of years, close to couple of years, we have had an Enterprise Plus variant of it. So Enterprise Plus has a higher SLA to offer, as in like 4 nines, which is also the case with AlloyDB. Enterprise Plus offers you advanced DR capability called as read pool, apart from having the normal read replica. And there are many other features, for example, more advanced generation of processors that it supports, including the ARM based Axion processors and so on. So a lot of work has happened on Enterprise Plus, and it is kind of moving much faster. So just to give you one example, like if you want the read scalability, you can have this read pool created, which can grow horizontally and shrink based on metrics like how many connections it is supporting, what kind of CPU load is there, right? So you don't probably need to run it in a more what we call static way if your workload kind of is spiky in nature, right? So there are a lot of features in this thing. So this is something that we introduced last year, and is a very relevant feature which many of our larger enterprise customers, for example, the bigger banks that operate here and use it, they are kind of using it. The second is the advanced DR, which I alluded to. So advanced DR, what happens is like typically if you have to invoke a DR, especially in regulated industry, there is this concept of performing the DR drills, right? So let's say, for example, every quarter or every 6 months, these banks are required to demonstrate that they can operate fully functional from another site for certain number of days, for example 1 week, right? So doing this drill has to be kind of bring in a lot of orchestrations, because it's not just database, there are a lot many other components that also have to operate from there, right? But database becomes one of the most significant components, because if there is any kind of data loss, that is going to happen at DB layer, not somewhere else, right? And for those industries, I mean, like one single transaction could be worth 1 crore, or it could be worth 100 rupees, right? At the end of the day, it's just one record in database, so we can't lose it. So we have something called as advanced DR. You just have a cross-region replica which is designated as a failover replica, and you, I mean, like, have those options available in console. You can do it using our G-Cloud SDK, or you can also do it via Terraform. So there are ways and means available by which you can orchestrate or execute these DR drills, but it is very what you call hands-free kind of approach. It will ensure that your primary automatically takes over the read over / secondary role. Your cross region replica, which was until now a read replica, henceforth becomes a primary. So this becomes a very smooth thing. The more critical or the good point is that there is a write endpoint, which is nothing but a private DNS, the internal IP, that gets associated with the writer instance. So wherever the writer instance is, it is going to be connected to it. Okay, so you don't have to essentially make changes in your app tier, because app tier is always going to write to the primary, and this write endpoint, as the name indicates, is always going to point there. So this is also something that you don't have to deal with. Okay, at the time of provisioning, whenever you create this cross region replica, designate it as the cross region replica. These things come into existence in a very seamless way, okay, as part of the provisioning cycle itself. Any question here so far? And by the way, I mean, like, I might have made a statement that everything is available in LOIDB also in a certain different way. Okay, so while I am calling out the terminologies which are more cloud SQL specific here, more or less it is available in LOIDB as well. Okay, so I think I explained this, right? So simplified disaster recovery, as you could kind of make out, that we just have to do it as a one-time activity, and then it's available all through the lifetime of the instance. Second is replica failover. As I said, these are the options which become available to you once you kind of set this cross-region replica. So whether you want to do a switch over or you want to do a failover. Now what is the difference, right? You do a switch over, for example, to demonstrate that yes, we can operate from the other side. It's a drill. Okay, it's a demonstration. You will actually do a failover when you actually encounter the situation. You are actually in a downtime, a region is unavailable. It usually doesn't happen, but let's say you are in that situation where your primary is not available, so you will have to do a replica failover in that case. Okay, and then what happens in that case? As soon as your region becomes available back again, the one that went down, this instance which was running actually as a primary at that point in time, it will come up again and it will get plugged in as a secondary instance now, because the primary has now already got activated onto the other side. So this all happens under the hood. So see the benefit of, I mean, just kind of adopting this platform as a service, and so much of toil is kind of avoided and taken care of by the control plane or the orchestration layer of the engine itself. Switchover, we spoke about it. Write endpoint, I already spoke about. Okay, so what are the other features, right? Say for example, manage connection pooling. The 4 tenets, one of them was connection pooling, because each connection going to the database is going to consume a lot of resources, and we don't want that. Better let's do multiplexing of connections in a right way. And PG bouncer, I assume all of you know or have worked on it. So it's a sort of a middleware based load balancing mechanism from Postgres standpoint, right? So it helps you to kind of keep the number of sessions or the database connections limited, although the traffic could be kind of much higher in terms of application level user concurrency, right? So managed connection pooling actually helps you by making this connection pooling again available natively within the engine. Okay, this is available again both in, okay, yeah, I was alluding to this, that all of this is also available in LOIDB. While I am kind of talking about it through the lens of Cloud SQL Enterprise Plus, it's available there as well. But again, connection pooling becoming available natively makes a lot of difference, but otherwise it comes as a bolt-on solution, right? So you have a managed database, but something which is still has to be managed by us. So that experience kind of becomes a bit hybrid. So with this, it becomes a very seamless data cache. Now, data cache, think of it like a layer of fast cache which is sitting between actually your SSD disk where the actual persistence happens and the DRAM, the shared buffers of the engine, which is the fastest part of the database, but we don't have the leisure or luxury of keeping everything in buffer cache, right? Let's say if your database is 10 terabytes, you are not going to have a DRAM cache which is 10 terabytes, right? You will have to have persistence layer which is SSD. But then what is faster than SSD is this thing. I mean, under the hoods, it is nothing but an NVMe cache which is attached to the VM which is hosting the DB. So this NVMe is going to be faster than the SSD. So you don't have to dip in and make an IOP to the SSD. At the same time, it is going to be a bit slower than the actual DRAM. The good part is this is available in much bigger size and quantity or volume as compared to DRAM. So anything that is available in data cache is going to be pulled up or become available as a end result set to the user much faster than a typical IOPS operation happening at SSD layer. Okay, and the last one, which I already mentioned about, that we also offer apart from x86 family, the ARM family based processors as well. They have their own features and price performance ratios. But yes, as a matter of choice, we get a broader option set over there. Again, available, all of these are available here as well. Okay, quickly the differentiators. Okay, so read pool auto scaling it is available in MySQL as well. So we just called it out, but let's kind of keep it in context of PostgreSQL. I think I spoke about it. There are a couple of metrics which can be used to make it auto. As in the two metrics that I spoke about is CPU utilization based and the other is database connections. Okay, so I mean it helps you to kind of put a what you call scaffold around like how you want to kind of scale it and to what extent, right? So key features, I think we already went through it. Managed connection pooling, I think I tried explaining like what is the essence of having a managed connection pooling, especially when your application has a lot of user concurrency and the all or most of the sessions are still going to kind of touch the database and connect with it, right? So again, just for the sake of clarity, Cloud SQL Enterprise doesn't has it, I mean like baked in. Enterprise Plus is something which is having higher availability SLA and a lot of other features including advanced DR, and so is the case with connection pooling as well. Okay, and I think if you have also participated in our quiz outside since yesterday, this was one of the questions like when would you have this connection pooling considered, right? And like what is the best use case for it? So you do it when there is huge amount of connections and they are short-lived. So typical OLTP connection which will just do a point read write and come back, right? We don't want to do a batch connections through connection pooling because that's sort of an anti-pattern over there. Yeah, so no manual proxy management because otherwise if it was not baked in, you could have otherwise provisioned a VM, put the binaries of PG bouncer, and then you would have kind of put the connection via it from the application tier. Okay, I think that's pretty much what I wanted to cover. I'll pass it on to Abhijeet for the rest of the slides.
Yeah.
So thank you, and I am available if there are any more questions. Definitely we can spend some time around it. So thanks for your attention.
Thanks, Tushar.
Over to you.
Yeah, thank you so much. I think that was fantastic. Thank you. I know I want to end on time also because it's going to be lunchtime. Everyone is hungry. I also want to leave 5-7 minutes for Abhirami to come in and talk about DevRel. So I'll touch and quickly upon few key messaging which we want to give it to you. Few key slides I'll run through. and if you want to see the other slides, you can always ask, and they're available on the booth. Any questions so far before I start? I mean, any managed connection pool? I know replication lag is something I'll cover again in AllIDB terms, but any correction or any questions, clarifications? Okay, great. So let's talk about one of the differentiated offering which we have, which is called the AllIDB. You must be familiar so far with this database because most of you have seen, couple of you in the training, many of you in the other sessions, also on the booth and on the quizzes and so on. So what we did, and as the name suggests, alloy is a mixture of two metals to make it better, and that's what we did is we took the goodness of Postgres, and then whatever technology Google developed over the past decades, we kind of engineered that into the Postgres, and now that becomes AllIDB. So these technologies are I would say, you can see it here, the best of Google innovations. These are some of the technologies also include storage layer, and then there are things which are we integrate with AllIDB, like AllIDB AI, which will give you a very seamless experience of actually. I don't know how many of you saw morning session where we showed you the SQL where you can directly call the AI functions like rank and so on. I mean, there are various functions now, AI summary. So whatever you see AI dot, that's the AI function you are calling directly from the SQL. Then obviously AllIDB has a columnar engine, so you can run your, it's a true HTAB database. I know some of you may not like want to use HTAB, but it's AllIDB is a true HTAB database, hybrid analytical and transaction processing. It offers a columnar engine which you can configure, choose to configure. You may not be have to have, but if your workload actually has some sort of analytical requirement, you can definitely configure that.
Quick point, it comes without any additional cost.
Yeah.
So, I mean, you don't have to pay anything extra for it.
Absolutely. I know Oracle is one I can say in this room which charges for in-memory option for columnar engine, right? So it comes as option, paid option, right? Obviously, it is one of the, because we are saying it's an enterprise grade database, so it's available 4 nines of SLA, inclusive of maintenance. That's very, I would say, demanding SLA for the enterprise to have the critical workloads. So as I said, probably we'll spend some time on this slide. Feel free to ask questions. This is the AllIDB, I would say, architecture. This is how we can say we have disaggregated the compute and storage. So we are using Google's distributed file system, which is Colossus, which has been powering many of the Google's applications, and Spanner uses it, BigQuery uses it, and all the billion user applications like YouTube, Gmail, Maps, you name it, actually runs on this storage system, right? Most of them also use a Spanner. And then on top of that, what we did is we built this intelligent database storage engine, which is internally we call Dogfish, which actually takes care of not writing to the disk itself, right? So you can see here no block writes, right? So once you return to the logs, your data is committed. Then it scales independently. Also, our storage is completely flexible. So if you drop a table, your storage gets reduced, and similarly your billing gets reduced. So it's completely flexible. We have seen databases where storage doesn't get reduced. Once you've grown, you have to pay that much, right? As I said, there's analytical accelerator, so you can choose to have this columnar engine in AllIDB. Either you enable, you disable. Many of our customers, they choose analytical accelerators on read replicas. So they keep primary for writing, and then multiple read replicas, they enable the analytical accelerator, which is the columnar engine. And beauty is, if say you come to me and ask for, I want to run a quarter end report for few days, 3 days, then I can create a read replica to you and give it to you, because my storage is already replicated across the 3 zones. Your read replica will directly talk to existing storage, so I am not paying multiple times for the storage cost, right? So my database size remains the same. In many of the other databases, you keep on replicating your storage, and creating read replicas will become a humongous task in itself. So I will give it you instance, you can run your report, Once you're done, we can destroy that instance. Your primary, your other replicas remains intact, right? Then another very key point here to understand is we can have the read replicas cache completely dedicated to their own query patterns, right? So if you are from finance department, your cache will be also based on your queries. So your finance tables will be cached there, or your query patterns will be cached there, and your queries run very fast. Similarly, other read replica may be dedicated to other department. Those queries will run tremendously fast on that one. So these are the certain big advantages on OLIDB, and obviously the storage is one which actually makes it possible. Any question?
Maybe you want to add a little bit about the why. A lot of people, developers also are interested in knowing why do you think it's fast? I mean, we have mentioned about the columnar to enable that, but even without it, it's
absolutely. So there are optimizations gone into OLIDB at many levels. So one is this architecture itself. Then there is a layer of caching, which Tushar also spoke, that how we added the cache, and it is there in Cloud SQL as OLIDB. And there is also some kernel level optimization gone in itself. So the way we have position or provision OLIDB, there is at certain kernel level optimizations specifically for it to run a Postgres that has gone into it. So it's the optimization at multiple levels. It's at hardware level, it's at caching level, it's at I would say OS level as well. Yeah. There are certain. So this is the columnar, because one of the interest area for all of you, columnar unit or columnar engine, what we call it. So we have the SIMD protocol. So we call it a CU, columnar unit. So no problem. So what happens is there are a lot of questions even in the training there was how the columnar engine operates, right? So does it have a persistent store, or is it only in memory? So it's only in memory. When your data is always stored in the row format, we don't store the data in the columnar format. So it's not physical. Whenever you update, for example, there was a query around update, right? What happens when I update my rows, right? So what we do internally is whenever you change the value of any column which is there in the columnar store in the engine, we mark that CU columnar unit as invalid. We go back to the disk, write to the log or disk which we have seen previously, and then refresh the columnar engine. So you, at any point of time, you will not get any stale data or wrong data. So it's always consistent. You don't have to worry about from where my data is coming, whether it's coming from disk, whether it's coming from cache, or whether it is coming from the columnar engine. At all times, it will be consistent. Right. So some of the AI innovations what we did in OLIDB is listed here, and we can go on talking about it because these are in topics in itself, but just wanted to give you a summary today. So we have enabled PG vector extension on OLIDB and added a new index form which is scan index. Many of you have seen already. So scan stands for scalable approximate nearest neighbor. Google has done this research over past 10-12 years, and Postgres by default offers only two types of indexes, IVF flat and HNSW, but we offer additionally very performant index scan. And it's not only performance, but at the time of building also it takes less memory. At the time of vector updates also it is I would say, I mean there are numbers here, I can go and talk about it, but almost 4 times faster for rebuilding and so on. So it offers benefits at multiple levels. Scan also, the way we store the embeddings, and we do not market it very well, but we also compress the embeddings on when you actually generate the embeddings on OLIDB, right? So the dimensions get compressed and it takes less of a space when you actually use vector embeddings in OLIDB. Right. So then we did spoke about AI functions, and there is a team here also which can go in much deeper. You can feel free to ask questions about AI functions. So one of the example was in the morning where we showed the AI.if, but there can be AI.rank, and you just give the prompt in the natural language, it will get back to you the results. You don't have to know about what you're asking the your database has to be there, or your columns has to be there, and so on. To get that data, it will just call a LLM and get you the results back. Then obviously natural language is the talk of the town. So NL to SQL is one of the big capabilities in AlloDB, where we can ask the questions in natural language and get the answers back in natural language. And obviously there are 3 new AI models we launched in AlloDB. So this ranking, multi-model, and text and image supports, including videos. So all that is possible. I know we are at 10, probably another few minutes, and then I'll hand it over to Abhirami. Ujjwal is here, so he is one of the chief architect for AlloDB Omni. So when we launched AlloDB, there was huge interest in the customers from various shapes and sizes, right? So there were customers from retail who wants to have the database on their store, which is may not be connected all the time. There are customers who want to run Postgres below the mobile tower, which may not be like completely. Some of the customers want to run it in very disconnected mode, and so on, right? So that's where we launched something called AlloDB Omni, and the name suggests Omni. That means it can run anywhere. It can run on your laptop, it can run on other cloud, it can run on-prem, and so on. It's available in 2 formats now, a container, and it can also run on a VM now. As I said, it runs anywhere. You get all goodness of AlloDB. You can get columnar engine in Omni, so you can try it out. We have the free, what I can say, trial program as well, so you can definitely try it out, AlloDB or AlloDB Omni. You get all the goodness of AlloDB, like automatic vacuuming. Vacuuming is a big problem. We all know, we are all from Postgres background, so vacuuming is a big problem, and that has been addressed fantastically in AlloDB. Automatic memory management, columnar engine we spoke about, and you also get a AI and natural language features in AlloDB Omni. With that, probably how much time you need? That's
Okay, you take your time.
okay. Yeah, so there is a lot of questions around, oh, why should I go for Omni? So you can see it here, the performance numbers yourselves, which we have done some benchmarking, and you can see compared to stock Postgres, AlloDB Omni is almost 2 times faster, and with the automatic IO now you can see almost 4 times faster. Okay, so now we'll talk about some of the agentic capabilities which we recently launched. I know we may run short of time, but feel free to come to the booth and we can have a further discussion. So as I said, we launched the multiple AI capabilities within AlloDB. So you can actually use AlloDB as a true multi-model. I can definitely say that you can do vector, you can do AI, then you can do normal RDBMS as well. So these 3 features you can see here. I can call LLMs, I can generate embeddings, and I can store it in AlloDB, and then I can use the AI query engine to do ranking APIs and so on. So all that is completely possible on AlloDB, and I think I covered this slide for those who attended the training, because agent is something which will help you to do these tasks. Like you can ask a query question in the natural language, it will go to the database and come back to you in a natural language. So it will understand what you're asking, your intent. It will check what are the tools available. It will check which data it needs to connect, and get back to you the results which you intend to do so. Right, and for that, initially we launch MCP toolbox, which will help you to connect. So let's not confuse MCP with the managed connection pooling. This is launched by Anthropic, the model context protocol, and this is more or less de facto now industry standard to connect to databases or any, for that matter, any source for which agent needs to provide to you, right? So now the MCP toolbox can connect to most of the Google databases, also some of the partner databases as well. So you can get data from different databases like Neo4j and so on. So even if you host your Postgres on Google Cloud, you can connect MCP and get that data.
All of these in the list are also supported now, by the way.
Yeah.
ClickHouse, that is not in the list. 47.
I think next slide.
57 databases are supported now.
Okay.
By MCP Toolbox.
Yes, perfect. But this toolbox itself was not enough. So what we launch is now manage MCP service. I think, yes. So this is what we launched recently, and which is available now for you to. So you don't have to install toolbox and configure it and connect and so on. What we offer is now on Google Cloud is manage MCP service. So now you can directly say I want to connect to say BigQuery database or Cloud SQL or RDB and so on. MCP will help you to directly connect. It will give you an endpoint. It's completely managed for you. So you don't have to worry about where should I install the toolbox, where should I connect and so on. So it's completely out of the box. And this is as recent as a few weeks back. So we just recently launched it because a lot of customers were asking for, I don't want to go through the toil of setting up MCP and so on. So that's where this managed connection, no, again I'm mixing the two terms. The MCP managed service comes into the picture. And this service actually offers many, I mean, you can invoke today Gemini CLI, and you can see that when you type MCP list, you will get the possible when they supported by the MCP, which you can directly execute. So you can execute SQLs, you can create tables, you can generate data and insert it and so on. So you can create even database. We have a fantastic demo. In the interest of time, I may not be able to show you, but we have a demo where we create the database, we create the tables, we insert the data, and we even MCP help us to optimize the query as well. Right. So that has been one of the I would say differentiator when we actually invoke MCP with the Gemini CLI. Okay, so I think this is the last slide. Just to I would say re-emphasize what we offer. We have three options of running Postgres in Google Cloud. One is the Cloud SQL, which is the as open source as it gets, right? So it's a completely open source offering which we do. It's a managed offering for your Postgres. Then we know the two options which Tushar spoke about, or Enterprise and Enterprise Plus. Both are available on Cloud SQL. We have the OlliDB. Again, there are two flavors we talked about: OlliDB on the cloud and OlliDB Omni, which you can install and run anywhere. And obviously, we have third offering, Cloud Spanner, which has a Postgres interface. That means that if you have application which needs to run on Postgres, you can run it on Spanner with the Postgres interface. Just to be word of caution, it's not a drop-in replacement. So Spanner may not be a drop-in replacement for Postgres applications, because some of you may be using PL SQL like procedures and triggers and so on, which may not be possible on Spanner. Okay, with that, I'd like to end today's session. Abhirami, you want to spend a few words? Yes, so there is a data migration service, Spanner migration service, which will help you to migrate. So that's a specific tool available from Google Cloud. Yeah, and also you can use third-party tools like Stream, which supports migration to Spanner. Stream is STRIM. Over to you. On this slide?
No,
Okay.
I thought it was Mike.
No.